right, next example. So these two are not in beautiful y equals and y equals form. So they aren't in standard and slope-intercept form for our linear on the top. So you have options. You can either isolate y, because that's what we've done for the last three, and get it by itself, or you can isolate x in the top one too and then plug it in. For this one, in my opinion, just because of habit, I think isolating y is going to be easier. So x plus y equals 5. I'm going to subtract x from both sides. And then I got y equals 5 minus x. And then for my y plus 1 equals 3x squared plus 2x, I am going to subtract 1 from both sides. There's not a constant here, so he's just going to hang out on the end like a good quadratic trinomial. 3x squared plus 2x minus 1. Now, these two are in the form like our previous examples, so we can just set them equal and then solve. So 5 minus x equals 3x squared plus 2x minus 1. We're going to combine like terms because, again, we're cross and we need to set it equal to 0. So I'm going to subtract 5 from my constant. I'm going to go ahead and put plus x as well. And it goes with the 2x because those are like terms. Sum of 0 equals 3x squared plus 3x minus 6. Now, another one of those problems where there's no multiple pair of 6. I have 1 and 6, 2 and 3, and that's it. And there's no way that either one of those are going to come together to give me a 3. Now, we do have a GCF of 3, so we can get that out and check it. So 3x squared plus x minus 2. Now, that one looks good. We probably can factor this one. So factors of 2 or multiple of 2. So I can get rid of this and we'll use our ACB chart over here. Multiples of 2 that add or subtract to give me 1. So 2 and 1. The 2 needs to be negative and the 1 needs to be positive. So our 2 has to be the guy on the front. So that means I'm going to have x plus 2 and x minus 1 with a GCF of 3 on the outside. All right. And then from there, we're going to set both of these equal to 0 and find our solutions. So x plus 2 equals 0 and x minus 1 equals 0. Again, crossing the equal mark, so x equals a negative 2 and x equals a positive 1. That 3 will never equal 0, so it's not a factor because there's not a variable attached to it. So sorry that looks all crazy. X equals a positive 1 and x equals a negative 2. So a list of our answers would be negative 2 and positive 1 would be our solutions. To find out the coordinates of both, you would plug those x values back in. So to the first one, for our first equation, if I have negative 2, see if I can make more space. So for our first one, we'll plug in negative 2 plus y equals 5 and solve for y. So we're going to add 2. So y equals 7. So for our first equation, when x is negative 2, y is going to be 7. Then for our second equation, it should be the same for x is negative 2. So y plus 1 equals 3 times the negative 2 squared plus 2 times the negative 2. So 3 times the negative 2 squared we got to do first because exponential laws, you got to do that first. That's going to be 4. So 3 times 4 plus 2 times the negative 2 is a negative 4. 12, basically minus 4 because plus and negative is the same thing. 12 minus 4 is going to give me 8. I need to subtract 1 from both sides. So y is also going to give me 7. So when x is negative 2, y will be 7 in both equations. And then you can do the same for our positive 1. So we plug in a positive 1. 1 plus y equals 5. Subtract that 1, y equals 4. So in our first equation, when x is 1, y is 4. And notice these are parentheses, not our squiggles here, okay? And then our second one, we're going to plug in that 1 in the place of x. So y plus 1 equals 3 times the square 1 plus 2 times 1. And 1 times 1 is 1. So this is 3 times 1, which is 3, plus 2 equals 1. Y plus, that's 5. And we're going to subtract 1 from both sides. So y is going to give us 4 in the second one as well. So we know we did it right. So the solutions to the two of them are indeed -2 and 1. And then when so our coordinates were 1 and 4, and I believe it was 2 and 7. All right, guys. Hope that made sense.